needed to see the
Sorry, Jackie.
That's okay. Teachers need to see the progression of the standards. They need to have that connection and also to understand that when you hear computer science standards, it's very scary and very intimidating for a lot of people. And we needed teachers to know that when you hear you have another content area and you have standards, it's not like the math, the ELA, the science or social studies standards, where you have, anywhere from 15 to 30 standards you have to teach in a year. So this poster really was the result of all those trainings and what we learned that teachers needed to be able to see. They needed to see that visual of what kids need to learn and to what extent are teachers required to teach it. Another thing I wanted to point out is you'll see, and sorry, Rob, if you mentioned this, I was helping another Zoom room really quick, but all those yellow cells, those are the standards that are required in the half-credit computer science class that all Nevada students have to pass in order to receive a high school diploma. If students do not have any exposure or experience with computer science prior to enrollment in that course, they have a very, very low success rate, meaning they won't pass the class, meaning then they have to go into credit recovery or they have to take the class again. So it's really important that at the K-5 level, students are being exposed to these computer science standards. So that's all I was going to say about it.
No, I appreciate that. And I think the key, I haven't been a classroom teacher in elementary, and Jackie certainly was and has had great experience at this, but I really, if you're in my last session, you understand what I'm talking about, but I really do believe that the easiest or the best way to do this is not to put a kid on a curriculum that has a laptop and they go through modules. I really truly believe that the best way for you as a teacher in elementary, if that's your job right now, is to integrate these across other curriculum and other subject matters. So it's a seamless that integration. So if you need help with that, we certainly have resources and reach out to us that way. But that's one of the best successes we've seen, is not teaching them in isolation. Most of these standards, if not all, can be integrated with other content area and should be. And we actually have a state document where it actually has the standards and it actually lists different NVACs or other subject matters and standards that they could match up with when you're teaching them. Okay, any questions about the poster or standards themselves, how they're broken down? Please feel free to jump in on the chat or to unmute and seek clarification. Yes.
The NVAX poster that's aligned or that you just referred to, may I request a copy of that?
Yeah, so actually we can put it in the chat as well. So that's a link. So if you go to CSNV or STEM Nevada, I think Jackie's probably really fast. She'll probably find it right now for you.
So it's just the standards booklet. It lists out all the standards, and at the bottom, it shows you the cross-curricular connections. And I believe it's also on the NWRPDP website. At least it used to be. I doubt it was taken down.
Yeah.
But it's just the standards document. The first section of that document, I'm not going to lie, it's over 100 pages. Because it has the computer science standards, and then it also has the integrated technology standards. Because we have two sets of standards, we have computer science and then we have the integrated technology. And both of those are combined in there because both of them are required. So just know in the first section, that's where you're going to find computer science. And at the bottom, it will show you all the cross-curricular connections.
And again, and Teresa, we'll grab that when we have the resources in a little bit, and we'll open it up and look at that for you so you can see where that's found. Okay. All right. So any other questions? Let's go ahead and look at some of this, how it's broken down in a nutshell. So if I was to look at the different concepts of computer science, we have algorithms and programming. That's the kind of the meat and potatoes, I want to say. Maybe it's not the best thing. That's how I kind of think of it for computer science. That's where the programming, that's where you code, where you're dragging and dropping blocks, or it's where you're typing in Python or C. And so that's the actual programming section where you decide what your program is going to be. You decide how it's going to be laid out. You decide what the inputs and the outputs are going to be. Is it a screen? Is it something graphical user? Is it like a picture on the screen and you're asking people to click on it? So what does that program really want you to do? What are you trying to achieve with the program? For example, middle school students, when they're studying Spanish vocabulary, they decided to create a little app that would have the vocabulary words, and when they want to click on the app, it would flip over backwards, the little flashcards. And so they made their own flashcards, and so programming it to have flashcards, putting in the words, interacting with the touch. That's really where the algorithms and programming, and that's where honestly most teachers in elementary that haven't had any training in computer science, that's where the struggle becomes, and kind of where the fear is that Jackie mentioned, that, oh my gosh, it's too much, or I don't know it. That's really where some of those challenges lie there. Not to chase you away from it, but 41% of the standards in the K8 grade bands, if you put them all together, so almost half, so 41% of those standards are located there. So that's a really heavy item. When we're talking about computing systems with students, we're talking about actually the hardware and the software. We're talking about the screen, the keyboard, the mouse, the printer. And so teaching kids those things and how they interact is what that category is. Data analysis, when we talk about that one, by the way, your computing system is 14%. Data analysis is, what do you do with data? Do you graph it? Can you put it in a spreadsheet? Is it something you're going to look for in a database? What are you doing with information? And then also importantly is, how is it stored? That's where kids learn about binary numbers, ones and zeros, and how data is stored in the cloud or on a hard drive or whatever the case may be. So that's where that information is taught them.
So I will also add that within data analysis is data visualization, data science. So I know data science is a big thing right now. There's conversations going on nationally and even internationally around data science and the societal need for students to become more familiar with it. If we learn anything from COVID is that data can be presented in a number of different ways based on the story it's trying to tell, right? So within data analysis, that's also where they start looking at how they can present data or how that data visualization is processed in it. And so for 5th grade, it's really important for them to get in there and look at all that stuff.
Cool. Yeah. And
sorry, I didn't mean to interrupt you.
oh no, that was good. I appreciate it. No, you keep going. The 4th category we want to talk about, we'll break down a little bit today, is impacts of computing. And this really is that digital citizenship and how computers have impacted our society, how it's changed, good, bad, or different. Unintended consequences are in that category. So just making sure kids are aware of how it affects them on a day-to-day basis, or how our society has changed, and maybe what that future looks like. What do we want it to be based on technology? Because we've all been on this earth long enough that we know times in the past where it wasn't like what it is today, obviously. And there's pros and cons to that. So that's where we teach kids about that information.
And also with the impacts of computing, like Rob mentioned, the integration into other disciplines, that's a great opportunity to pull in ELA standards, have them writing an argumentative essay, giving a speech, doing a Socrative seminar, all that kind of stuff, to really understand not just the impact that society has had on technology, but how has technology changed our way of life? And a lot of it is getting creative with even exposing kids to what life was like without technology, because our kids don't know it. They have no idea what it's like to go to the library and have to search through the card catalog or the microfiche. They do not know the pleasure of a Ditto machine, you know? So these are things that we have to really expose them to, but then also provide those opportunities to have those really deep conversations. So I just want to share, like, impacts of computing. I always see that as a great opportunity for ELA connections and also social studies.
Yeah, and great tie into even those digital citizenship stuff. I mean, if kids understand when they take a picture and they send it out to the world, or to even to a site, that if they understand those consequences of what that looks like and where it goes and who can intercept it and who can get it, I think truly, honestly, when people, and just not students, but when people in our culture understand the impacts of computing and things they do personally and how it impacts their life down the road or currently, I think maybe, hopefully maybe decisions are made better in the future or in the current state. I don't know. You'd hope they would. The last thing we want kids to understand in the general categories is called network and the internet. So how is information shared? You have your cell phone, and I just shared a picture of Yosemite National Park with Jackie. How's that image sent to her? How are those colors sent over the internet? And how's information sent? And is it from one computer to the other? What if it only part of it gets sent? Hey, what does that spinning wheel mean when my computer looks like it's got the wheel of death, we call it, or it's spinning forever? Do students understand really that might be information being weighted? We're sending packets back and forth, and it's trying to get the packets and compile them all together. So understanding how information is sent, how it's protected, passwords, right? How to keep information safe. I mean, there's thousands and if not probably millions of jobs about network protocols and internet and keeping data secure and your business information secure, and how do you somebody not get your bank account information? So it's important for kids to understand, even us to understand how that information is sent out and received. So that's the basic breakdown of computer science. And so is what we want to do at the time we have now is just kind of take a journey through the different grade levels. And if you teach 5th grade, maybe with the perspective of, what's being taught before me? Or if you teach kindergarten, and once we've gone over yours, maybe what's taught after me. So I apologize if I'm going to talk about I shouldn't apologize. I'm not going to apologize for CS. It's awesome. But if we hit kindergarten, look at what's being taught after you, and what role you play in the educational system of helping kids as they progress through CS. So kindergarten folks, and once again, please feel free to jump in, ask questions, clarification as we go. So kindergarten, within those 5 concepts, you see you only have 8 standards total, as Jackie mentioned. It shouldn't be overwhelming, but we're hoping you understand the importance of it as you go on. You're just modeling. You don't have to do any programming. You're just modeling algorithms and programming. So maybe you model lining up in a line for getting out to lunch, and it has to be tallest to shortest, and you have to fix the errors. So modeling things in other subject matters. So how are patterns done? Computing systems, you're just teaching terminology. This is a screen, this is a monitor, and you can look at the standards for what those are, but you're just teaching them how to identify parts and pieces. Data analysis, basically that you can collect stuff and you can store it on a device. That's the extent of kindergarten. Impact, I like this because it's with teacher guidance, and it's not like the students have to do it. It's with teacher guidance. Make sure they understand. I think it's like something with passwords. Jackie probably hasn't memorized what that one is, but with teacher guidance, understand the importance of good digital citizenship, and I think and clicking on links and things like that, and password protection. So that's the basics for kindergarten. Jackie, you want to alternate? You want to go first?
Sure. Grade? Okay, so 1st grade, it says describe and model, and that's really where they're getting into just that process of understanding what an algorithm is and what are those problems. So like if they look at the song, like Old MacDonald, the chorus is it's like a loop. It's technically it could be a function, but it looks at how it's repeating over and over again, how there's all these different things in our lives that are connected through the term algorithm, and how that then goes into coding. For computing systems, they are looking at what's the appropriate device to use for different situations. So if I'm going to sit down and write a letter to my grandma, we're going to assume kids do that, write a letter, we'll say an email. Is it more appropriate for me to do it on my phone, my laptop, my tablet, a desktop, or maybe all of them? If I want to edit a video, if I want to edit a video, should I do it on my phone or should I do it on a desktop? If I want to go on an airplane and be able to watch a movie, should I take my desktop computer or should I take my laptop? It's really just kids making those connections with what's most appropriate for the given scenario. For data analysis, all they need to know is that data can be stored and you can find it. So if I save a file on my computer on the desktop, then tomorrow I can log into my computer and I can access that document. If I save it in the cloud, like Google Drive or Microsoft iCloud, anything like that, I can log in there and then I can find it. When they look at the impacts of computing, it's really building on that digital citizenship. Like, be kind to others. Don't harass people. Make sure that you're doing the right thing. And then same thing with networks and internet. It extends on kindergarten from just don't share your password to don't share any personal information. Don't share your name and your address with people you don't know online. So that's essentially first grade in a nutshell.
Okay, so in second grade, we have 9 standards. So it's a little bit heavier on this, and it's really in that algorithms and programming section. There's 4 standards there, which is almost half of what it is in second grade. But this is where we start to introduce the idea of sequencing and loops to kids. And decompose is just break something down into smaller parts or smaller pieces, and then setting a plan or a goal to whatever your outcome is. And attribution is I'm just giving credit. So if I'm going to create something and somebody else had the idea, I want to go ahead and give them credit for something they did. So think about opportunities for sequences and loops, bringing that into the classroom of what do kids do that are loops or sequences that they'll repeat throughout the day. Probably music is a great one for this when you're going over chorus or you have something that goes back and repeats itself again. It's a great tie-in with sequencing and loops you can do that way. So look at those standards. They'll break it down a little more, but just that's where we're getting a little bit heavier of a lift, where kids have to understand that we can repeat things. Because the cool thing, like video games even, I'm sure by second grade, most of them play video games. And maybe you talk about how the character jumps over an item and you want to create that jump function or that jump command. You don't code it every time as jump and rewrite the code. You just go back and refer to it once you've built it and doing that. So that's the algorithms and programming, a little bit heavier. Computing systems, we're starting to describe with appropriate terminology the different parts and pieces of the monitor, the keyboard, the mouse. And I don't think it actually gets, I have to go look at them. I don't think it gets into inside the computer yet. That level, but just make sure you're describing with appropriate terminology. The difference here, Jackie mentioned you can store it. So we talked about how they can store and they can get information. Now we teach them the fact they can copy it. And then we teach them, we can search for it by a certain, search in an Omnibox or a keyword. And then we can actually modify it or delete it. So not only can we just store it and get it back, but now we can copy it, we can modify it, we can delete it. And then impacts of computing, that's that past and present, safe and unsafe communication. There's 2 standards there, look at that. And then lastly was strong passwords. Okay, so it's not something, you look at that, you look at the standard, but basically strong passwords, not just using their name, first name and last name as their password. So how would you make it stronger for somebody so they don't guess it or try to steal it or get into your stuff?
So third grade is where it really starts building on the complexity in computer science. Not that it's like super complex, like it's not expecting you to go and write lines and lines and lines of code, but it's really getting more into that block-based coding and identifying where the errors are and why it's not working. So it introduces that concept of debugging and trying to find out where there's an error and how to fix it so it'll run. If you look in computing systems, it's where they start identifying internal, external parts within a device or within a computing system and how those work together to create a computer. So we have hardware and then we have software. So really recognizing the fact that I think many of us on here, when we bought a computer many years ago, we had to buy the disc, the CD, to download anything or to install anything, and now we just download it. It's the same thing. Or when you buy a phone, you have to download all your apps. It's really them making that connection that the computer is comprised of internal and external parts, including peripherals like a mouse or a keyboard. Data analysis is where they get into that data visualization and just like taking a set of data and organizing it and presenting in a manner to support something they want to say. And then impacts of computing. This is my favorite one in third grade, because this is where they start looking at the influence between society and technology. And if you look at third graders, it's so appropriate for them at that age to really start having these discussions, because that's when most of them are getting more involved in social medias or communicating with friends on technology, all that kind of stuff. And then networks and the internet, again, it just extends on protecting personal information.
That's a fun one, because then they start doing ciphers and different, you know, A means really B and B really means C. And so they develop some sort of encryption on a really simple level. That's kind of a fun one too. All right, fourth grade, you have 8 standards there. So half of them are that algorithms and programming stuff. So they're testing and refining. So they're actually writing some, and like Jackie said, block coding. A great program is Scratch. If you've never used Scratch, I suggest you look that up, but it's block-based coding where the kids don't have to know the syntax. They just drag and drop blocks that mean things. So maybe they're having maybe you're tying it in with ELA and you're doing storytelling, and maybe they have the cat going down a path to grandma's house. And so they're going to be dragging and dropping blocks to send the cat down a various course or whatever, the obstacle course. And so they're going to test, they're going to refine it. Can you make it shorter? Instead of doing 20 blocks of code, can you do it in 18? Can you do it in 16? And then there have some conditionals. This is that logic thinking now. So if this is that, then something will happen. And so where really computer programming comes into play is those logic statements. If I build a program that asks somebody their birthday, then my program is going to have a picture of the time of year where their birthday is. So if their birthday is in the wintertime, maybe I'll have a Christmas tree or snow falling if it's in North America. If their birthday is in June, then maybe a picture of the beach will come up. And so those types of conditionals is what they're trying to learn. Decomposition is breaking something down into its more element parts. And once again, debugging. Computing systems, now they're going to model it. So now they understand the vocabulary. It's like, how does the keyboard send the letter H to the monitor? So maybe you can model the letter H having a certain signature or a certain binary number, and then somebody's going to carry it to the monitor and they're going to put it on the monitor. And so just kind of model how things work. Cause and effect. Biggest one here is predicting outcomes. So now you know that the bar graph does this. What's it going to be down the road? So that type of stuff with data as they develop those as they developmentally, and seeing that cause and effect stuff. Impacts, compare past and present. So that's something Jackie talked about. And then the last one in model or networks internet, now they're going to model the transmission of data. So maybe you have a piece of paper with a message and you're going to cut it up into pieces called packets, and you're going to send it through a router, which is a student who's got to be like the mail person and send it off to different directions. And then how does it get to the specific user? So you're modeling how information is carried back and forth to teach that concept.
So fifth grade, we're just building on everything. Fifth grade is where they start to get really heavy in algorithms and programming. But again, I want to stress that in that concept, the kids are still only working with block-based coding. It's not like you would typically see a very advanced coder or programmer using where they're typing the syntax and all that. It's, using things like Scratch, code.org. There's so many block-based systems out there that they can use for coding. And looking at ways developing computational artifacts. So if they want to develop a game where they collect points, okay, well, what are all the little pieces that I need to do in my code or my program to make that happen? So that's where the decomposition comes together. And then again, like Rob said, it just extends on all the other grade levels, really ties it together so that they see how computing system and data analysis ties in with coding and programming. Yeah, so that's pretty much it.
And that's the first time we get binary too, by the way, in your standards. So pick up on binary, ones and zeros. Computers, that's how they talk and communicate and store data, unlike humans. Okay. So then what happens in our 6th to 8th grade, just so you know that if you're in the middle school, that you have 24 standards that need to be taught at some time between 6th to 8th grade. That half credit course does cover some of them. If you remember that poster we showed you with the yellow on it, but almost half, 42% is in the programming stuff. You can see the percentages there. So once again, algorithms and programming becomes the majority of what they're doing as they're developing their computer science skills and understanding. We did the progressions. I think we've showed you that chart. So the question is, well, what curriculum do I use? What can I do to teach these students? Because I don't want to reinvent the wheel. Know that there's a wide variety of curriculum that is out there. Jackie mentioned code.org. I mentioned Scratch. Scratch isn't, I don't know if it's necessarily called a curriculum, but it's a tool we can use. But so the question is, well, what's out there that I can use in my classroom? What is there that I can take to my principal or to my district and say, hey, I need some resources because I don't have time to reinvent the wheel. I'd like to see what's out there. And so the state of Nevada, I'll let Jackie handle this one, but they've come up with approved curriculum that has been compared to the state standards, and they've been given, for lack of a better word, the stamp of approval that yes, this one will work. And so I'll let Jackie, I'll show this Jackie if you want.
Okay.
To talk about those.
Because then I have to log off because I have to go do raffle prizes.
All right.
My favorite part. So anyway, so in case you did not know, it says in NRS that all computer science instructional materials that are designated as a core curricular resource within the classroom, meaning you're using it 70% or more in your classroom, it has to go through a review and approval process. And we gather a group of stakeholders, educators, and administrators, all that, and they really go through a rigorous review process, looking at standards alignment, social justice, equity, accessibility, all that kind of stuff. So, and then once we get that done, then we have to present it to State Board of Education for approval. So we just recently, well, on September 1st, actually presented a huge list of resources, and they were all approved, which we were really excited about. So we have a lot of curricular resources on there that can be used by teachers and schools to teach computer science. Also at the bottom, that section that Rob was just showing, those are supplemental resources. So they didn't necessarily meet the requirements to be considered core instructional materials, but they still had some really great stuff in there, like CodeMonkey. They have some great coding platforms in there. They just didn't hit all the standards. So you could potentially use CodeMonkey to cover some of the standards and then supplement in other ways. So it's not to say that those are the only things that are out there. There's a lot of OER stuff. CS Unplugged has some great unplugged activities. Scratch is really good. It's really up to the teacher's discretion on how they teach the standards. You just have to be teaching the standards. That's it. But this is a great starting point to look at some standards aligned resources.
Thanks.
So I'm sorry. Yeah, do you have any questions for me before I have to go do raffle prizes? If you ever have questions, you can always email me. I did put the NDE computer science website in the chat, and my email is on there, and then Rob can also share it at the end. Okay, bye everyone.
Thanks, Jackie. All right, so there's a list of approved resources that you can go and look at, that you know that if you are going to use them, that they've been vetted by the state and they have the approval. So if your admin says, are they vetted, there's your resource list that as good as of September. So here's some other resources to help you in your journey on teaching computer science. If you don't know, there are 3 RPDPs throughout the state of Nevada. There's the Northwest, that's the one that I work for. And then there's a Southern Nevada. And then there's a should be Northeast. It should be a North. Should be an NN, Northern Nevada. So that's out east. I guess there's an E there for east, but their website is NN. So it depends on where your school is and where you work. You have various resources for professional development. And if you want to certainly reach out to an RPDP that's outside of your area, then they have trainings in classes that you may be able to join if it's a statewide training. So check those resources out. CS for NV. So the question was earlier is where do I find those standards? So if you go to CS for NV, it's an updated site that's for STEM and for computer science. And so if we go to CS for NV on the far side here, this is what we were talking about earlier we wanted to show you. Under the Educators tab, you have Nevada Computer Science and Integrated Technology Standards. So Jackie mentioned they're all together in one document now. And so if you click on this link, I'll share the slide deck with you in just a second. So let's go look at the standards here. So this is the Nevada Integrated Technology and Computer Science Standards. And if I just jump down to page 10 and 9 and 10 has an example. So it goes through and talks about the concepts there we did. So here's an example for kindergarten. It's algorithms and programming, algorithms, and you have one standard, model daily processes. So below most of the standards in this document, there are the NVACs that have been crosswalked to other subjects that would correspond with this standard to help you teach it. And so for science, there's cause and effect, there's patterns, evaluating communication systems and models. So there's some science connections there. For math, it's the SMP standard, no, not standards. I'll think about it in a minute. Standards, mathematical practices, I think it is 6, 7, and 8. So those practices have examples of things that could tie into this. And then you also have for ELA, there's a couple standards that you could also potentially teach with this one. And that's from various people around the state who've got a computer science background and a background in these various other contents that we looked at all the standards and said these would be ones you could crosswalk and integrate them with. And so there's an example. So in that electronic document, please use that, look at it. Hopefully that'll make your life easier in trying to understand how to match or merge computer science standards with other content areas. This is an interesting one here. So I'm not going to click on the link, but there's in the link I'll send you in a minute. This is if you want to learn more about computer science. This takes you through each grade level and each standard and has a breakdown of what it means. There's videos there. There's references to other online material that would help you understand the basic concepts of computer science. So if you're like, man, like Robert, I just don't know computer science. I never learned it in college. This number 4 here is probably, as far as self-paced and on your own, is a great resource for you. CS Unplugged. This link is a great one if you don't have devices in your class. I have a budget of X, Y, Z, and it's not enough for me to buy devices. My principals put money to other places. What do I do in the classroom? The power's off, the internet's down, whatever. CS Unplugged is an amazing site that breaks down by different contents and has all the lesson plans for you on unplugged activities, things you can do without a device that still teach the concepts of computer science. There's another unplugged one. Scratch is the one I talked about earlier on that. Tinker is a great one. There's some free resources on Tinker. There is a subscription. I know some schools put some Title I funds towards Tinker subscriptions. There's great curriculum there if your principal pays for it, but there is some free ones there. Code.org is probably the biggest popular one around the state of Nevada because the state of Nevada has partnered with Code.org. Code.org is a great resource for putting kids and helping them understand computer science. Also, if you check with Southern Nevada RPDP, I know most of you folks are there, with Jason at the RPDP office, they teach one-day sessions on code.org that help you understand computer science as a teacher. And they basically take you through how to use code.org's curriculum, but it's a great one to get some foundations for computer science. Hour of Code is, whoops, come on. Hour of Code is a great resource. I think we have one day every year. It's Hour of Code. We have Computer Science CS Week, where Hour of Code is done. So look at that. An amazing resource there. And come on. I know that's not it might be my last one. The other one I want to plug in, and then I'll share these resources with you. And then the time you have left, you can just jump in and check those out. The other thing that the state of Nevada is doing, what might interest you guys, is we have collaborated with all 3 RPDPs, and we're offering a statewide computer science endorsement. Now, the great thing about that is it's 3 college classes through SUU, and it's $63 for each 3 credit class. So 63 times 3, so it's at $189. So for $189, you can get your CS endorsement through licensure. And that the really cool thing is, you may not be teaching CS like as an isolated, subject matter, but what I really like about that endorsement is that it provides you with the base knowledge and understanding that you may not have received in college now that you're required to teach computer science. It's like, whoa, now I have to teach it, but I have no idea what it is. If you do that endorsement course and take those 3 classes, you'll be well on your way to making sure you're confident and you know how to teach computer science in your class, and you really know what algorithms and programming is, and your understanding is huge. So I really would endorse that. So check with your local RPDP. I know we're starting another cohort. I'm hoping it's gonna be this spring, but definitely in the fall. And when you see that course comes out, we did an open enrollment and we had over 400 people interested in it, and we only had 40 spots. So if you're one of the lucky few people to be on there, then you know the journey you've been on. But if not, look for that to come out through a Southern Nevada RPDP or through your local RPDP if you're not up there, that we're offering that statewide endorsement. So I'll share the link with you, the slide deck. So I'll do that now. And I'm also going to put in your attendance thing in the chat. And then I'm also going to put an evaluation for the session. And so time-wise, I'll get that done. And if you have any questions while I'm doing this, go ahead and unmute, and I'll try not to be, I'll see if I can multitask and get it out to you. So give me a second to get that. Okay, so the first link is your attendance for today. Let's see, here it is. This is where it helps if I have a co-pilot going. So there's your link. Go ahead and do your attendance while I'm doing the next link for you. And the next link will be if you have time, you want to do a session evaluation, great. If not, I get it on time. So let's go there. Come on, computer. Okay, so here is coming your session link. And then the last one I'm going to send you is the slide deck. So you have a link for that. And you have those resources then.
Hi, those last 2 links are the same.
Oh, thank you. Let me see if I can go for 3 in a row. No, hopefully not. Okay, let's try this one. So this one should be the slide deck. Okay, somebody verified that's right. So the last link, was that for the attendance on both of them? Yeah? Okay. So I will get you.
We need the one for the eval.
Eval, thank you. This one. Okay. Okay, there should be your eval link, the last one I sent. I appreciate you guys. Our time is virtually up, so I'll hang on for any last questions you have. And I think there's 2 sessions left. If you're going to go to them, hopefully you enjoy those and enjoy your.
That's still not the eval.
Still not the eval.
Yeah. That's the attendance. You keep putting the attendance one out.
Well, this thing is lying to me. So
It's marked wrong, maybe. I don't know.
Okay, let's try this again. Well, I'll be darned. Okay, so I am on the eval. I copied the URL. I'm just walk you through this, and let's try it one more time. Looks like the same one, isn't it? Well, I'm happy you have the attendance. Oh, I'm not sure why it's doing it. Let me go clear the browser real quick if you want to hang out for that. It's crazy because I have it right there. Let me refresh this and see if I get a different one. Okay, this is a different number now. Dun, dun, dun. Okay, I believe this is different. Let's find out. Control V, 719. Nope, it's exactly the same. I'm not going to give it to you 4 times in a row. Okay, so we're just going to chalk it up that I want you guys to move on to your next session, and I just don't know why it's not doing that. I don't want to lose you on the Zoom. So any emails, send me an email, any questions or help you have, or but you do have the slide deck, right? Can we confirm that you got that? Okay, so you have all the resources there. So good luck in your computer science journey, and I'm available if you were up north, or if you just want to send me an email and you want something. Those posters, you want any of those posters? I know I had promised some a while ago in my other classes, but I have some fresh off the press, and so we are ready to send some out by email. So if you want any of those posters, or you can go get them on our website link on NWRPDP on the computer science stuff on those tabs down below. Okay, so send me your email so I see yes, please. So fire me an email of who wants those, and then I will record that and get that off to you. Okay, there you go. Thank you. All right, you guys have a great one. You can bug out anytime you want, or hang on and ask me questions. You're welcome, Donna. Welcome, Teresa. Have a good weekend left of it. And James, I'll get you one, James, for a poster as well. I'll email you guys and get your address, and I'll send it to your mailing address. I'll email you separately on that. You're welcome.